Gauss-Jordan elimination. Let's get right into it. So here we have a problem that should feel pretty familiar for many of you if you've studied linear algebra before. We're given a system of three equations: x plus y plus z equal 3, 2x minus y plus z equal 2, 3x plus 2z equal 5. As we can see here, we have three variables, x, y, and z, and three equations. To solve this system, we're going to convert it into an augmented matrix. Starting with the first equation, the coefficients are 1, 1, 1 equal 3. So that's what we're gonna write down here. We have our augmented matrix. 1, 1, 1. I'm gonna draw a line. 3. In the second equation, we see the coefficients as 2, -1, 1, and equal 2. And in the last equation, we have 3. We don't have a y variable, so we place 0, 2, and 5. Now that we have our augmented matrix, let's begin the Gauss-Jordan reduction process to get it into reduced row echelon form, or simply RREF. And remember, we have two goals. Each pivot should be 1. All other entries in that pivots column should be 0. Let's look at the first pivot in the first row. It's already a 1, so we're good there. Now we need to eliminate the numbers below it in the same column, specifically the 2 that we see in the row 2 and 3 in row 3. So in order for us to do this, we're gonna perform some row operations as following. So we will do row 2 minus 2 row 1 in row 2, and row 3 minus 3 row 1 in row 3. Now let's update our matrix. We have 1, 1, 1, 3, 0, -3, -1, -4, 0, -3, -1, -4. Do you notice something here? We notice that row 2 and row 3 are identical. That means we can eliminate one of them since they do not give us any new information. So what we're going to do now, we're going to try to eliminate the last row. And the way to do it, we're going to perform the following row operation, which is row 3 minus row 2 in row 3. And that will give us the new matrix as following: 1, 1, 1, 3, 0, -3, -1, -4, and 0, 0, 0, 0. As we can see, we got rid of the last row, so the last row now is all zeros. Now, let's make the pivot in row 2 a 1. Currently, as we can see, it's -3, so we'll divide the entire row by -3. So let me copy this in a new page. And the row operation we're gonna perform here is, as we mentioned, we're gonna divide the entire row by -3. So I'm gonna do row 2 in row 2, and again update our matrix. So it becomes 1, 1, 3, 0, 1, 1 over 3, and 4 over 3, 0, 0, 0. Now the matrix looks like this. Now we want to eliminate the one above that pivot in column 2. So what we'll do now, we'll do the simple row operation, which is row 1 minus row 2 in row 1. And let's update our final matrix, which becomes 1, 0, 2 over 3, 5 over 3, 0, 1, 1 over 3, 4 over 3, 0, 0, 0, 0. And that should be the final shape. And we've now reached reduced row echelon form. And now we can interpret this matrix back into equations. So from row 1, we can see that we have x plus 2 over 3 z equal 5 over 3, or we can say that x is equal to 5 over 3 minus 2 over 3 z. And in row 2, we have y plus 1 over 3 z equal 4 over 3, or simply we can say y is equal to 4 over 3 minus 1 over 3 z. And in row 3, we notice that we have all zeros, so row 3 does not give us any new information since it's all zero. We now know that x and y are basic variables, so let's write this down here. X and y are basic variables, while z is a free variable. And now we can write our solution in a vector form. Vector form, we have x, y, z equal 5 over 3 minus 2 over 3 z and 4 over 3 minus 1 over 3 z, and z, we can just place z. We can also simplify this and make it in this format. So we can separate this here in a vector and separate this one in a vector and take z as a common factor. And that's what we're going to do now. So our final solution should become 5 over 3, 4 over 3, 0, plus z, negative 2 over 3, negative 1 over 3, 1. And that's the final answer in vector form. I hope this walkthrough helped you understand how Gauss-Jordan elimination works and how to interpret the final matrix into a vector solution. I'll be solving more linear algebra and linear programming problems in future videos, so stay tuned. If you have any questions, drop them in the comments below, and thanks for watching.